Welcome to Inspiring Innovation, where your host, Sean Frost, is joined by experts in the manufacturing industry to discuss bringing big ideas to life. Join us every episode for a deep dive into manufacturing trends, processes, innovation, and how to be successful in the ever-changing world of manufacturing.
I'm going to do a little different intro today. We had a national sales meeting in which we had a little bit of fun introducing our speakers, and one of those was Carla DeShaw. And so I'm gonna bring it to you like we did at our national sales meeting and really announce this with a different style. So, ladies and gentlemen, prepare yourself for an electrifying episode featuring a true luminary in the realm of innovation. She's not just a leader, she's the undisputed champion of pushing boundaries and redefining what is possible. So, coming to you direct from our national sales meeting where she stole the show and left everyone in awe, she's the trailblazer of the next generation of product developers, seamlessly blending creativity and precision. She's the go-to expert in the intricate arts of sewing, sealing, and thermoforming. Get ready to be inspired as we welcome none other than the remarkable Carla DeShaw to our podcast. Stay tuned as we unravel the secrets behind her unparalleled success and delve into the world of cutting-edge innovation with the one and only Carla DeShaw.
Thank you, Sean. Thanks for having me.
Yeah, we're glad that we have you at Polo Custom Products. You are truly an expert, and we have a lot of new people and experienced people at Polo, and you bring the experience and you really hold the newbies' hands and do a great job of training folks and answering our questions and keeping us from developing bad habits in this custom manufacturing world. But today I want to really deep dive into our capabilities. And so one of the things that we do a lot across all of our industries is radio frequency sealing. And so I wanted to ask you, how does RF sealing contribute to the durability of the products, especially some of the larger ones? Can you share an example of a project where the RF sealing was really crucial and maybe difficult to figure out, but Polo came through?
Yeah, actually, all of our sealed projects and products, the sealing is crucial because with RF sealing, the unit or the product needs to be watertight or airtight. So it's crucial to have good seals. With RF, it uses a high frequency radio waves along with pressure and cooling to basically create the shape we're wanting. It fuses the layers together, which it takes the two layers and creates it and bonds it into one, which creates a stronger material, a thicker, heavier material. It's a great process for drainage bags that for laparoscopic surgeries. Also, we have compression boots that inflate, deflate. So it's got to be able to hold air. So it's crucial across any product that we're sealing to make sure that the RF seal is consistent and strong across all areas of the product. There is one product that we worked on. It actually was a spin-off on the compression boot that we produce. This is a boot actually for lymphedema patients, swelling in the leg. But there was an extraordinary patient that our customer had that none of the boots they had would fit. And this patient was actually looking to lose his leg if they couldn't get the swelling down. So the customer came to Polo and asked, is there any way that, we could custom make a boot? Gave us the size we needed. And we got busy working with the team, the setup manager for RF, creating some mock tooling to actually build a boot for this patient. And one of the things that we really love is our customers will give us feedback based on our products. And the operators take pride of that on the floor. We sent this off, and I believe it was over 46-inch diameter is what this compression boot ended up being, because the RF manager and I were able to stand in the boot after we had it
Nice.
completed. But we did receive information back about a month later that what we did and going above and beyond actually did save the patient's leg. So
Wow.
that was great. And that was crucial that we had one chance. We needed to be able to get this boot to hold air and compress as it should and get that out in a timely manner.
Mhm.
And
Mhm.
it worked out.
That's amazing. Yeah, I appreciate you sharing that story, and I always enjoy being with the smart people around the tables that really the inventions of the future that we see in our emergency rooms, in our hospitals, and our firefighters and our America's sons and daughters in the war fighters. So it's incredibly meaningful, the materials that you guys work with, the inventions that you create with the engineers that we work with, the large OEMs that we work with, and you've got an incredible team. And so that's another example that I hadn't even heard yet of you guys going above and beyond and saving someone's leg. We do have class 3 FDA devices that save lives, but that's a really great story. Thank you for sharing that, Carla. Can you talk when it comes to RF welding, what are maybe some of the common materials to use for RF sealing and maybe some that may be the right fit for that capability specifically?
Yeah, it's usually a thermoplastic or a film layers such as PVCs or urethanes is mainly what Polo uses. That's the best types of materials for the RF sealing. As we'll get into later, there are other sealing capabilities that we have for other materials, but generally the PVCs, urethanes are what we use.
Is there anything to stay away from if you're considering an RF sealed product, like types of materials at all?
So you want to stay away from more of the polyethylenes, polypropylenes,
Okay,
those types of materials. Mylars, Tyveks, nonwovens are not good for RF sealing.
perfect, perfect. So how about impulse sealing and hot air welders? Are there advantages to this? What's the difference in sealing with an impulse seal or a hot air welder versus RF sealing?
Okay, hot air welder is actually easier to use. It doesn't have as the detailed tooling that you would need. It's used more for larger products, more like curtains, mattresses. It can even be larger bags or even a duffel bag because you're able to actually maneuver the materials around with curves and edges. It actually is the process you want to use for complex or difficult areas to get it for sealing because you can seal more 3D with hot air welding. But it's better to use materials more like a scrim or heavier PVCs. You can even hot air weld webbings that are coated with a PVC. So if you're wanting some strapping on a larger bag or duffel bag, you can use the hot air welders for that. But most of the time, hot air welders are for much larger products. And impulse welding is actually something that is extremely quick. The machine does not have to preheat when you actually press the buttons for it to activate. That's when you're receiving the electrical impulses. It goes through a heated wire, it bonds the material, and as soon as the process is done, it's instantly cool. It's quicker, uses very little energy. There is a wide range of materials you can use for impulse, easier to set up and more consistent, but it also has a smaller range. So it's not for larger products, more smaller products. And you can use materials like your polypropylene, polyethylene, foils, and mylars, even not Tyvek and non-woven. could be used with impulse sealing.
Nice, nice. And is the tooling process similar for impulse sealing to RF sealing?
They are totally different. RF sealing, you actually need to make sure you are actually creating the tooling for the thickness of your material. So the thickness when you're sealing RF is important because of your tooling being stepped for different thicknesses. So that's where when materials are received in at Polo, we go through a process of inspections just to verify that our material thicknesses are consistent and fall within our tolerances so that we know we'll get a good seal when it goes into production. With Impulse, it's it uses a heated metal wire, and the wire is actually coiled in the shape that you're needing the seal. It's a longer lead time to get the tooling, and it is more expensive compared to RF tooling.
That's helpful to know. And then the other sealing process capability that we have is ultrasonic sealing. How does that contribute to precision in sealing and bonding?
Okay, so ultrasonic sealing is basically more of a precision. It narrows down and focuses on a smaller sealed area. You're able to seal like straps together or seal some hooks and loops, but it's on a smaller scale. Normally, you want something with ultrasonic, it's generally within 10 inches or less, is what you're wanting, but it's a very small surface. Ultrasonic is meant for overlapping materials and sealing as an overlap and definitely a flat surface.
Perfect. And are there any other limitations or considerations you should make if you're considering an ultrasonic sealing process?
Yeah, the ultrasonic is, like I mentioned, it's better for flat surfaces. It's not as effective of a weld if you're trying to seal like around corners or joints. There are lengthy lead times for the specialized tooling you're needing. It takes the specialized machines, but then you have to buy, they're called horns, and that's the tooling that actually will create your seal.
Well, let's dive into sewing. When it comes to sewing lightweight materials, how do you approach sewing lightweight materials to ensure both the strength but also flexibility?
Yeah, that's a good question because we have to look actually at the end use for that product first
Mhm.
to decide how are we going to finish the seams. Is this something that maybe we need to add a binding around the edges to help reinforce the stitching and the seams on a lightweight material? There's not just one factor to consider. You basically need to look at the stretch of your material. How much is it stretch, or does the material tend to draw up? The type of foot on your sewing machine as well for lightweight material and thicker materials as well. We would look at it for both, but the lightweight, it all depends on your needle, the type of foot. We've got standard feet and then we have walking feet. And the walking foot actually will tend to keep your material from either stretching or drawing up as much. So those are factors that we take into when we're looking at lightweight material and trying to decide what's going to be the best machine for the best stitching. Thread is also a factor because your seam is going to be as strong as what your thread and your material is. That's what we also need to look into when using lightweight material. And we do, if we review, the customer has given us what the end use is, and we feel that it may not be the best material, or we have maybe a better solution or a better material, we will suggest that so that the customer has options going forward.
Yeah, that's fascinating. And I know there's examples. I don't know if I'd say it's particularly for lightweight materials, but where we've worked with our customers to really ask the questions about how are you going to test this? How much weight does this need to bear? Where is it going to be worn? Are people going to wear, for instance, like a rope bag? Are they going to put just one one arm of it on their shoulders? Or are they going to wear it with two? How much, strain and stress does that need to test? And so I found that to be helpful with the cross-functional team that we have involved in these processes to really dig into how the product's going to be used and what we need to test for and how it needs to be sewn accordingly. And that's one thing that really, I think, resonated with our national sales team group was something that needed to test for multiple tons of weight. Can you share a little bit more about that product and what it had to test for?
Oh, yeah. Yeah. We were producing a strap to hold cargo down, basically on the backs of a semi, but it was a 4-inch wide webbing. And we needed to come up with a stitch pattern, or this strap needed to hold over 10,000 pounds. It needed to handle that much pull. We had to look and actually develop a stitch pattern along with the type of thread that would withstand a 10,000 pound pull. So it took a lot of smaller stitches, but even a zigzag pattern back and forth in order to come up with the correct stitching and a correct amount of thread in the webbing and the pattern to basically pass testing. It took us a couple rounds to basically send off to the lab because naturally we don't have the testing capabilities in house for 10,000 pound pull, but it took us just a couple rounds to be able to get the strap to pass, and then we were able to move into production with it. But it was a collaboration with the team, the design team, engineers, production, basically sitting down and figuring out how wide the pattern needed to be with the stitching and how many stitches is it 7 stitches per inch, or should we be going more like 9 stitches per inch just to be able to get that strength.
Mhm. Yeah, that's impressive. I'm always thankful that your team is working on solving some of these problems because I don't know how you do it, and it does take a lot of bright people working together in the same direction to figure it out. But can you give an example of products where the choice of sewing machine significantly impacted the final outcome?
There's quite a few that a lot of it is going from a flatbed single needle machine where you're having to manually run it through the machine to actually going to an automated tacker.
Mhm.
We had a tether early on, and this tether actually held the lid to the tub of the bag. And it was done, it had to have 2 rows of stitching and 1/8 of an inch apart. We started just with a flatbed single needle machine. But for efficiency, we were looking at how can we keep this consistent and keep the same stitches per inch, be able to keep the stitching at 1/8 of an inch apart. And by looking at it, we were able to move it over to one of our automated sewing machines. It would automatically sew across and then sew another line exactly 1/8 of an inch across so that it would look good to the end user. It was more efficient in production, and our throughput was much faster.
That's amazing. And then I don't know if this is a good question or not. In what situations are cylinder arm machines particularly useful, and how do they enhance the sewing process? You may speak a little bit to the different types of machines that we do have available to really shed light on our different capabilities. I know when we say industrial sewing, there are some very intense materials that we work with and a wide range of capabilities that represents.
Yeah, we do have quite a variety of sewing machines. We have several cylinder arm machines. We also have post machines. And then we have machines that are more heavier duty cylinder arm that's used for thicker leathers. And those will actually are used for more of our saddlebags so that we can get into the tight corners So cylinder arms and post machines are used primarily to get into curves, corners. It opens up the area more because you don't have the bed of the machine in your way. It's the arm is extending out into the air basically so that you can get inside the product that you're sewing, and it just makes it a lot easier to maneuver and holding the part as you're sewing. Same with the post. The post machine, again, we evaluate whether to use a cylinder arm or a post. Just depends on where you're actually sewing on the product. But again, that is used for really tight areas, curves, corners that you need space around and you can't actually use a flatbed.
And are there specific challenges when sewing complex designs or patterns?
Yeah, there is. Actually, with any not with any kind of sewing, there's challenges just in fitment. You've got to learn how to hold the material as you're placing it under the foot of the sewing machine to keep it from stretching, drawing up. And it just depends. If you're using a lycra material, very stretchy, you have to handle that in a different way than you would with a thicker, heavier Cordura material. It's just so the operators have to learn. And that's what one thing with the design team is we basically review how we need to handle that material and help the operators with it as we implement it into production so that they're able to lessen the learning curve as it starts up.
Absolutely. That's definitely why training is so important too. And we've got some really great training personnel in all of our locations and some classes that they take before they can even get out on the floor. And that's really valuable because I know some of our products have over 300 sewing operations in them and are pretty complex pieces. So, yeah, I appreciate you shedding light on how complex that is and how many different factors go into that. So, let's switch gears to thermoforming. How do you choose laminate materials for thermoforming, and what considerations go into this decision?
Yes, again, that's where we need to know the intended application for the end use of the product because we need to know how rugged should the material be. Does it need to be wipeable? The material definitely it needs to stretch so that as you're forming, the material is giving and, and, and actually creating the mold that we want. And you also have to have the right type of foam. So we need to look at how dense do they want this? Do they want a little give? Do they want it hard as a rock? You have to look at the density of the foam. It definitely needs to be a thermal foam so that it actually will bond to the outer material and the lining material. The lining material, then you have to also be mindful of the product that's going inside the bag or inside the product because you have to make sure the lining isn't rubbing off if it's rubbing against the unit somewhere. So all of that is how you need to is how you actually choose what materials to use.
Mhm.
And if the customer, customers will come and say, this is what we want to use and give us a material. But then there's some where we just sit down with them and go through, here's your options. And these what we feel will work for you. And that's great when we have, and on any of these with normal sewing or even sealing a product, bringing the customer in and sitting down with our design team to actually go through and build and choose the materials at that time. And when they leave, we have a good mindset of how we need to move forward with building those. So yeah, back to the question though that you asked on how do we choose the materials for thermal forming is basically that we need to know the intended end use of the product. And then we can basically go from there. And if there's anything they're looking at for wanting it to be able to wipe it clean, if it needs to be maybe a little water resistant, we'll take all that into consideration as well.
Yeah, I definitely encourage our prospects or our customers that are in the development phase to get out and get across the table with your team, because I've, heard testimonials in terms of people saying, I got more done in 3 hours in Monticello, Iowa, working with Carla and her team than I have in weeks at my office just working in isolation. And that's one of my favorite things to see, is just the troubleshooting that goes on, people looking at materials, talking about different operations or ways to make the material or make the product do what it's intended to do. And so that's one of my favorite parts of the job, is to see the collaboration that takes place, something that we always encourage our customers to take advantage of.
Yeah, we love to show off we have a resource library so that we can pull out swatches of different materials. And we may not have it in house, but our raw material suppliers will have it. We can show them swatches and bring it in. And the design team will actually get more information face to face with the customer on the actual product than going just through emails or just maybe a 30-minute conversation over Teams or Zoom or something.
Mhm,
So we
mhm.
really do encourage any prospects or existing customers to come in.
Yeah, I couldn't agree more. I love how Teams and Zoom has allowed us to move business forward without always being in person, but it's so great when you get to actually sit down and touch and feel and collaborate, and you're not just in a Teams meeting that you're ready to get off of to go to the
Yeah.
next meeting. I think so much more gets done and relationships are built that really move both entities forward, and that's the whole mission of Polo, is to contribute to the growth and success of our customers. I definitely enjoy that the most out of anything that I get to do at Polo, is sit with your team and with our customers, OEMs, and manage or product managers and engineers and smart people. It's really a joy to watch. So, how can you share a case where thermoforming added some unique features to a product?
When the product is not in use, it's stored in this case. But when they do need to remove this product from its storage, they want to be able to compress the sides on this thermoform case. So we've got the thermoform top and bottom. The sides are collapsible. So that way they can actually then slide this case into a smaller storage area while they're using the product that was inside.
So, what's the preferred method for adding logos? I know we've got a range of ways that we can do that. Can you share a little bit about how we've approached that with different types of products?
Yeah, we have multiple ways of attaching logos for customers. Like I had mentioned earlier, we can actually deboss the logo. We can deboss or emboss depending on whether they want it actually pushed down into the material, into the maybe the seal product, or if they want it maybe raised and pops out on a seal product. We have silk screening so that we can screen a variety of colors to give a more appealing look to a product. We use that more on smoother materials or materials with more of a light grain or light texture to it. We have heat transfers. Heat transfers is endless on what your logo could look like with a heat transfer. That will come, we bring it in, and that's used on materials with more of a defined grain. It's also used with materials that maybe with our silk screen process, nylons that need to run through a heat tunnel to cure the ink. And this could be a material that maybe just shrinks too much. And we can use a heat transfer. And then the heat is basically adhering this transfer, but only in the area that you're needing the logo. So the rest of the pattern piece or body piece is not affected by heat. So it keeps the size. We don't have to worry about any shrinkage. We also use sew-in labels. So if the customer is wanting a sew label, if he's got a patch, we can sew a patch on. We also, for urethanes, urethane is a difficult material to try to get a logo to adhere to. We have some specialized inks for urethane materials. We also have foils that we can use, and foils you can get in multiple colors to create the look the customer's looking for with urethane.
Nice. I can almost just hear the requests for quotes coming in now that we're diving deep here. I think a lot of folks are going to want to work with Polo after hearing all of these different capabilities. And then, do you mind talking about laser cutting and how that contributes to precision? It's nicely automated and it helps with intricate designs or cutouts.
Yeah, laser cutting is a fairly new process that we have at Polo, and we love it. It's definitely making it more precise for us when we're cutting. We're finding that even with a urethane material, we're able to seal the product. And of course, you can't actually strip the material off like you normally would with PVC. You can't tear excess material off. Urethane is so strong that you have to either die cut the perimeter, or we found that laser cutting is a much better option. The laser cutting stays more precise because of the program that actually is built. It focuses the laser in the area that needs to be cut. Much more precise. We can hold tighter tolerances with it. And it can
That's great.
also handle complex shape.
That's great. Yeah, it's amazing for a really high volume running product, and we've definitely realized some efficiency out of it. Can you talk to quality control in manufacturing? We've had a whole deep dive episode with Don on it, but that's one of the things that we've touched on a little bit, but I think from a product development standpoint, it's good to hear about the cross-functional team that we have as we're developing the process. And what insights does your team in collaboration with quality incorporate into our manufacturing processes and our testing and our inspecting procedures?
Okay, so you're kind of wanting to know more high level, how do we actually incorporate the quality into our development phase, right?
Absolutely.
That's
Yep.
it. Okay. Yeah, we have definitely, like you mentioned, a cross functional design team that includes quality. So we have a quality representative on assigned to the team, and they are on that project from the beginning so that we're ensuring quality is built in as we're going through our processes, as we're building our processes. If the customer has certain requests that they want us to perform or that we need to meet, the quality is helping the design team build those into our processes. They're helping us in creating the testing parameters so that we're sure throughout the manufacturing process that quality is there and consistent.
Yeah, that's great. And I know manufacturing's involved and has input on how this might work with machinery or what's needed with the tooling. And it's definitely a great group and a lot of procedures in terms of even the way that we go through a process of quoting and sampling and first production. And do you mind just telling them a little bit about our phase gate process?
Sure. We've implemented a phase gate where we've got different sections that we follow through with our projects. The first phase is research and development, and that's basically gathering all the information that we can from the customer and figuring out or basically finding out what do they want from Polo? What do they want us to actually do? Develop their product? Is it something where they just want us to duplicate? We get our basically our finding our path forward on the project. Once everything is gathered, then the cross-functional team comes together and we have meeting to discuss what needs to be done. If there's any questions, everything is answered. Everyone agrees we're moving forward in this proper direction. So that's a gate. We're moving through a gate. Then the second phase is basically the development part, and that's where the project will kind of linger for the duration until the customer gives us an order. And this is developing the product. It's either giving the customer estimate quotes, giving them samples, drawings, CAD drawings, whatever the customer is requesting. We kind of stay in this phase until it's developed. The team, we have to go through the PFEMA process in this phase as well to make sure that we're looking at every possible area and mitigating any kind of issues. This part of the phase gate includes quality, engineers, representative for manufacturing, and then, of course, a product designer and a project coordinator as well. And they're all working together to develop the product. It stays in this phase until the customer says, yes, we want to place an order. Then we move into the next phase, but we have to go through a gate. Everybody, the team is on the same lines. This is how we're moving forward, and everybody agrees. Then we go into bill of manufacturing prep. So we start prepping for production. That's where we start looking. The team is looking at what equipment, what toolings, is there shop aids that need to be created, everything that production is going to need so that they can make this efficiently. Once everything is gathered, bill of manufacturing is completed, then we bring the team together again to make sure the processes are understandable. We have implemented not just documenting verbiage on how to put a product together, but we now have videos to show operators how to actually place it on the machine, how to hold the material. And there's visual work instructions as well. So instead of just words, we've got photos and we've got videos to go with it that really help the manufacturing process.
Yeah, I'm glad you shared that. Our customers love hearing about our visual bombs that we're implementing, and I think that's going to be very helpful. And it's a very thorough process, and it works across all the different industries that we serve to ensure that we're able to launch, scale, and reach high volumes for these products and ensure that no steps are missed as we add machines to the line or just continue to scale up. Really impressed with that process and the team and the way that people are signing off on what needs to be done at every level. One thing that you mentioned, it segues well into our last question here, which is I think that visual bomb is innovative and a way to integrate technology into what we do. How do you stay up on the latest technologies in manufacturing? And then is there anything that else or more on that you want to talk about that excites you for the future?
Yeah, so the team actually attends trade shows. That is a great place to see new technology and upcoming innovation. So we try to get the team out each year to different trade shows across the US. We also have trainings that come up from our equipment suppliers. They will send us if they're having any kind of trainings or any new equipment that they're wanting to showcase, basically. We get that. We do a lot of looking at and finding new processes even through YouTube. That is a big one.
Nice. Yeah, there's a wealth of resources out there. And Carla, I can't thank you enough for your time today. I think we're going to have a lot of people reaching out to want to work with you and your team. It's obvious that you know what you're doing, that you guys are the experts within the capabilities that we provide, and that we've had huge success with lots of product launches and lots of SKUs over the years and really supported our customers' growth and success. So thank you so much for joining us today, Carla.
Thank you for having me. We look
Yeah,
forward to working with the customers. Yeah, the team is ready and eager to get started with anything. And I know
sure.
we've talked about the ultrasonic sewing machines because that is a really big one that we would love to get into because it's more efficient with sewing and faster than the traditional sewing machines. So we're really hoping that there'll be a product that we can utilize that type of technology in the future.
Nice. Yeah, that sounds exciting.
I just had to say that because I really want
Yeah,
somebody to bring us a project.
right. Hey, internet.
Yeah.
Come out here, audience. Find us something to use that technology. We're eager to get our hands on
I
it.
want that machine.
I love
No,
it. I love
no.
it. Thank you for joining the podcast today. Inspiring innovation was really touched on. We talked about the products, the process to invent these products, and the technology that goes into it. And it's amazing because I feel like these capabilities have been around for a long time, but we always find new ways to apply them to the products that we take for granted in our industry. So we really appreciate having Carla on. Please tune in to future episodes. They're released every second Tuesday of the month, and we appreciate you listening.